All right, great. Hello, everybody. Welcome back. I think it's more or less the people we expect to be here. Before we get started, let me make sure everybody has it on their agenda that we're not going to be meeting next week because it's Ascension Day. So there will be no meeting next Thursday. The university will be closed. I mean, whatever that means in these days, but we won't have a Zoom meeting. And then in 2 weeks, we'll have David Schuren, who will be presenting current work against functionalism in the philosophy of physics, if I understand that correctly. And then one more meeting in the very last week of the semester where Maria Nergard will be presenting some work that she will communicate in due course. So about a week or so before, I'd like to send out an announcement more or less a week before the time, or maybe the Friday before or so. That's basically the deadline. All right, but without further ado, then let's get started. Baptiste will be presenting today joint work with Sam Barron, whom you've all met last week, about quantum gravity and Mereology. Please, Baptiste, take it away.
Yeah, thank you, Chris. Thank you all for tuning in. I really hope we'll have the opportunity to meet in person soon. Some of you, I never met you actually, so really love to do that next semester, perhaps. We'll see. So what I'm going to present today is a joint work we did with Sam on quantum gravity and Mereology. And what we are after in this work is the concept of extended simple. All right. And so the question is straightforward. Is the world made of extended simples? Right. And I use this fake beer as an illustration for that. Right. Because it can basically trigger your intuition pump. The idea is that the world will be made of uncuttable building blocks, either in the form of atoms, that will be material extended simples, or space-time quanta, spatial temporal extended simples. So of course here, if you are strong enough, you could break out the little pieces making this beer, the Legos. But the idea will be that ultimately the world is made of really uncuttable building blocks. And interestingly, a number of philosophers have argued in favor of this view of extended simples on the ground that they are needed by fundamental physics. And the arguments typically appeal to theories of quantum gravity. So let me mention a few persons making some claims in that direction. So here it's Brian Greene. Strings are truly fundamental. They are atoms, uncuttable constituents in the truest sense of the ancient Greeks. From this perspective, even though strings have spatial extent, the question of their composition is without any content. Here is Craig Callender now. On its most natural interpretation, superstring theory posits extended simples. I say most natural because the theory was initially motivated by the fact that the topology of interacting continuous one-dimensional extended entities avoided the ultraviolet divergences that plagued graviton-graviton scattering. The one-dimensionality of strings really is a significant part of the original attraction of the theory. And finally, here is Rettler, who say both theories, so here it means both loop quantum gravity and string theory, both theories entail the existence of extended simples. If string theory is true, then there are extended simples, because strings are extended one-dimensional simples. If loop quantum gravity is true, then space is discrete, so its smallest parts are extended. If an extended simple fills up some, but not all of an extended region, then there is a part of the region it fills up, and so there are regions smaller than it. but that's impossible. So if loop quantum gravity is true, the smallest things are also extended. But now, the beginning of this way was triggered by a reaction. But wait, is quantum gravity really pointing in this direction of a discrete space-time and of uncuttable matter objects, or rather of the unreality of space-time? Indeed, to date, arguments from physics in favor of extended simples have ignored the fact that the very existence and fundamentality of space-time are put under pressure by quantum gravity, and that space-time could be emergent, right? So the thought is really, well, if space-time might fail to exist or to be fundamental, it seems that the very notion of extension required to define the notion of extended simple would be problematic, would be put at risk. So there will be now 3 parts in the presentation. I will first present very roughly the situation in contemporary physics. Then I will introduce some physics-based arguments for extended simples. And then I will assess the arguments against some metaphysical models of the emergence of space-time. So I think the paper is not too challenging if you read it slowly, but there are many little pieces in this paper, many parts. So I will try to present most of them, but I will have also to pass on a few things. So hopefully you should be able to follow the talk, even if you didn't read the paper, but it will probably be easy if you did. But we'll see how it goes. Right, so let me first say a few things about the emergence of space-time. There are different ways, actually, different sorts of properties we usually ascribe to space and time that could turn out to be missing according to quantum gravity. So, for instance, there could be the case for spatial distances or temporal durations, or both. We have hints in that direction from 2-dimensional string theory, 10-dimensional string theory, causal set theory, Penrose conformal cyclic cosmology. If those names ring a bell, that's great. I'm happy to discuss about them later if you want. But if you really have no idea about what I'm talking about, it's not a big deal. Just be aware that some theories threaten these properties we usually ascribe to space and time, namely spatial and temporal distances. The ordering also is put under pressure in some approaches. In string theory, we have the issue of explaining the linkage between a 4-dimensional structure and a 10-dimensional structure. The time dimension itself could be emergent in particular version of shape dynamics. Or for instance, to take another example, the very local difference between space and time might itself be emergent in the sense that it will not exist everywhere in our physical world. All right, so what I'm going to do now is just to give you a bit more background in string theory and loop quantum gravity, to then introduce later the arguments for extended simples. In string theory, well, first thing to say, I guess, it's that it's the most popular theory of quantum gravity at the moment, in terms of the number of physicists involved. It's often presented as a prospective final theory of everything, which is a strong claim. And the view describes a world made of one-dimensional entities, as we saw, the strings, at least in some versions. Those strings are incredibly tiny and rigid and may oscillate with various frequencies, giving rise to phenomena then that we categorize as the particles and fields in our less fundamental theories, generativity, and the quantum field theory used in the standard model for particle physics. So the idea is to start from the standard model of particles, and then seek to recover gravity in a similar way via the view that gravitational interactions are mediated by a particle, the graviton, which is then itself reduced to a particular state of a closed string. But it's not only, we are not only, I mean, they are not only aiming at replacing, so to speak, point-like particles by one-dimensional strings, they also want to replace the four-dimensional space-time by a 10-dimensional structures for reasons of mathematical consistency. And the 6 spatial dimensions, the exotic dimensions that have to be added as then curled up on themselves in the standard view, they are said to be compactified. And then the 4th space-time dimension emerged somehow from the 10-dimensional structure. Now you could say, well, according to what I would call a naive understanding, there is no problem of space-time emergence at all, right? Just that the additional dimensions are compactified and we fail to notice their existence when we zoom out. So it would just be that space-time is actually 10-dimensional rather than 4-dimensional. So we will be redefining our concept of space-time rather than saying that it does not exist. It doesn't apply truthfully to the world, right? It would be more rigorous, put it like this. So it's a research program with no comprehensive and sorted out ontology. And the best thing we have at the moment are perturbative superstring theories that rely on 10-dimensional structures. But the reason why I said that it was a naive understanding that space-time is 10-dimensional rather than 4-dimensional is because of the existence of relations of duality. Because if you take the spaces of solutions of the 5 series, you have strong relations of equivalence between the solutions in the different series. And one of those sorts of relations is T-duality. And it relates worlds that seem to describe worlds with different spaces, different ways. The further exotic dimensions are compactified. So faced with this situation, what we have to do actually is to relate this network of dual theories not only to a more fundamental non-perturbative M theory, which still has to be found, but also to GR. Right? What perturbative here means that it relies on strong mathematical approximations. Right, and the hope is to get a non-perturbative M theory that will not rely heavily on mathematical approximations and will give perhaps a clearer ontological picture of what's going on. So the thing is that it's not clear, to be fair, what's the metaphysical status of duality between the 5 theories. It's my understanding that we will never know until we actually get a fully worked out M theory, because then we will be able to explain why actually the 5 superstring series were getting part of the physics right. So we need basically to have it to know exactly why we have those relations of duality. So the important point here is that in any case, the spaces on which the strings live cannot be identified with the space-time of general relativity. Right? It's something that is that Nick Huggett has insisted on. It's called the common core approach to duality in string theory. And according to this popular understanding of duality, I mean, it's popular among philosophers of physics at the very least. So according to this understanding of duality, the M theory will be based on the structure which is common to all dual series. But that's the thing, it seems that such a core will not include GR space-time because even though those 5 superstring series are formalized by using relativistic space-time, since they have different structure, if we think that what's real, what's over there in the world is a common structure, then we have to accept that the common core that exists in the world is not spatio-temporal. So another way to put it is that although we don't know how this core will look like mathematically or ontologically, the target space, so the spaces on which the strings live, will have to go and to be categorized as mathematical artifacts that we project on top of the world. So it seems that we have strong hints in the direction of space-time being missing or emergent in string theory. Right. What about loop quantum gravity? So loop quantum gravity, second most popular approach to quantum gravity. It starts with generativity and it aims to provide a quantum account of the gravitational field with the hope of reconciling it with the quantum fields of the standard model down the track. And the fundamental posits of the theory are represented by networks of intersecting loops called spin networks. And those spin networks can be represented by undirected graphs, which is a mathematical object, a structure of nodes connected by edges. And of course, exactly what the nodes and edges represent is controversial. So let me mention a popular view, at least one which is on the table. A possibility is that each node in a spin network represents a 2D spatial surface, and that every edge represents a 3D spatial volume. So the idea is that a group of nodes and edges can represent an atom of space, like a cube can be represented as a two-dimensional net. So I recently bought a tablet, so you are going to discover my first attempt at drawings. So it's not great, so you know, but I'm learning, right? So here is my attempt to show that we could represent a cube with a two-dimensional surface. Interesting things to know: in the dynamical form of LQG, spin networks are replaced by spin foams on extrusion of the spin network structure through higher dimension, right? So just like we could move from a three-dimensional spatial temporal picture to a four-dimensional spatial temporal picture, is the idea that we can move from a 3D spin network to a four-dimensional spin form. I mean, it's also controversial for both spin networks and spin foams how to physically interpret the situation. But one way of interpreting spin foam is that you say that the spin foam structure represents a lattice of spatial temporal atoms, right? And that's the reading that underlies the idea that we might find extended simples in loop quantum gravity. I mean, as usual in quantum theories, many fundamental classical quantities are substituted by operators in LQG, giving as output discrete values, right? And so importantly for our purpose, errors and volumes are treated as operators, entailing that volumes and errors can only take discrete values, thereby offering, or so it seems, reason to interpret LQG as relying on an ontology of discrete entities. So there is, it seems, an important conceptual gap between generativity and LQG, because GR is continuous and classical, namely non-quantum, while the fundamental structure of LQG with its quantum operators appears to be discrete and quantum. So now I'm done presenting what I needed to present about string theories and loop quantum gravity. I want to say a few things about two notions of discreteness. The first is topological discreteness. Here's the idea that space-time is discrete in the topological sense, or discrete T, as we call it in the paper, when there are space-time points that are isolated. And what it means is that there is a neighborhood around each point that contains no other space-time points. And so space-time is constituted by this point. So very roughly, the idea is that in a way, a metric would be more fundamental in a way that you could have this sort of topology where you have relations between the points, you have neighborhood around the points, but you have no points at those locations. Fair enough, it's quite strange, but at the very least, it's one notion of discreteness which is on the table. And the thing to notice here is that if all extended regions, if space-time is discrete in this sense, right, then all extended regions have proper parts, namely the points that constitute them, right? You can see my pointer, right? So yes, okay. So if you take, for instance, this this part of space-time, right? It's really discrete, right? It's topologically discrete, but it has parts. It has the four points, like.
Are you, Baptiste, are you touching your microphone or something? Or somehow the sound is not as it was before?
Okay, no, I'm not. Is it, okay, sorry, is it working or? I don't know, or maybe I was doing some stuff with my hands. I didn't realize. I don't know. Right, and so of course, if space-time is discrete in this way, then the case for extended simple regions is dead on arrival, because it's not simple if it has parts. So here is a second notion of discreteness that we call region-based discreteness. And here is the idea that space-time is discrete in this sense when there are no space-time points. What you have are extended space-time regions that have no proper subregions, right? So if you consider this one, for instance, it's one of the building blocks of space-time. There are no points, it's just a collection of those guys that compose space-time. Right. And if space-time is discrete in this sense, then space-time is made of spatial-temporal extended simples, right? Or at least we don't have the, it's more promising than the first notion of discreteness, that the topological notion of discreteness I just introduced before. Right, so in the paper, we distinguish between two sorts of arguments. One could put in favor of the existence of extended simples. There is a first direct way to argue directly from a given physical theory. By, if we are lucky enough, perhaps we might find a physical theory that posits some entity X that is both extended and mergically simple, and then that would be great. Because a realist commitment to that theory then would be enough, would be sufficient to for an ontological commitment to extended simples. So call this a simple argument for extended simples. A second sort of argument one can make will be more indirect and require a bit more work. And because what could be the case is that could be the case that a theory does not directly posit on entity X that is merologically simple and extended, and so that realism about the theory alone will not be enough. But perhaps a case could be then made that we can infer the simplicity of some entity, posited nonetheless by the theory, by combining realism about this theory to other independent plausible principles that will go beyond the content of that physical theory. And so we call those arguments harmony arguments because they rely on a philosophical principle of harmony. So we took it from Saucedo and we modified it. So here is the harmony principle. X is a proper part of Y if and only if X location is a proper subregion of Y's location. We just modified it in the sense that it was originally formulated in terms of part and subregions, and we changed it in terms to put it in terms of proper parts and proper subregions. So it's quite simple what it says actually, right? Just let's put it like this, right? You can think of objects as having a mereological structure, right? So take this object E, it has P as a proper part. And now you can think of this object as being located somewhere at a region. So E will be located at R, and its proper part P will be located at R star. So R star will be a proper subregion of R. And the idea is that location will ensure the harmony of the two mereological structures, right? So the idea is that if you have the object E located at region R, and E has a proper part P, you should expect the region R to also have a sub-entity, a subregion. So we go quickly on the argument. I put it here if you are interested, if you didn't read the paper. But what I want to insist on is this condition here. E as a proper part P only if there exists region R stars such that R star is a proper subregion of R and P is exactly located at R star. So L here refers to exact location. So very intuitively, the idea is that so you can think of this by using my little drawing. If there is no region R star here, right? You can expect the object located in the region R not to have a proper part P. So it's basically a way to link object to regions. So these sorts of arguments that I just outlined are standardly aimed at theories of quantum gravity like LQG and string theory. But I guess you start to see the problem, right? Because if I mean, it seems that extended simples presuppose a viable notion of spatial temporal extension to begin with. So for determining whether physics implies extended simples, we first need to determine the status of spacetime in the context of quantum gravity. And so now I'm going to present the options that we list in the papers. Perhaps they are not exhaustive, but I think it's, at the very least, they capture different sorts of families of metaphysical views one may have about the emergence of spacetime. And so the first is spacetime eliminativism, right? And here the idea is that spacetime does not exist at all. It's probably not very popular, but Sam is quite attracted by it. And the more I think about it, the more I think it deserves, I mean, it's not that bad, actually. I think it has some merits. I mean, we'll see, Chris, you will see. Further work incoming on that. But anyway, let's consider it just for a moment, even if only to evacuate it then. According to the view, what exists is just some non-spatial temporal structure, and that's it. So space-time eliminativism undermines the case for extended simples entirely. Also, it seems, right? What seems to be the case is that if space-time does not exist, then nothing is extended, right? And if nothing is extended, then no simple is extended. No, of course, there is something here interesting, right? Could we have some kind of non-spatial temporal notion of extension, right? It echoes some discussions that Sam and Claudio had last week. And actually in the paper, we say that maybe there is room in that direction. But nonetheless, prima facie, it's quite difficult to make sense of that. But perhaps there is a way to do that. I will leave this here for now. But let's say at the very least, the case doesn't seem too good for extended simples if you don't think that spacetime exists, right? A second option is full-blown realism. So it consists in going a bit against the spirit of the work of, for instance, of Chris and Nick, and say, well, it's still possible that a conservative theory of quantum gravity, namely conservative with respect to the existence of space-time, will turn out to be correct after all, right? So let's explore this option, right? So the idea will be that absolutely all the concrete entities located in the physical world will be spatial-temporally located, and thus spacetime will exist at all levels of description, including the most fundamental levels to be described by the theory of QG. So let's look at this at the prospects of an argument for extended simples in this context. Although, I mean, I will say immediately that it's just like spacetime eliminativism is probably one of the less promising take on the situation in quantum gravity. So let's focus on strings first. I mean, here, I think we can settle the situation quite quickly. So Dave Baker already provides compelling reasons to suppose that strings do have parts, right? And it's just that they can be split and joined. And splitting and joining is what we would expect of composite objects, and certainly a lot of simples. That's the way we think of it. But here is the thing. Following Nick Huggett and Josh Norton, we note that it relies on a straightforward but particular interpretation of string theory, namely that splitting is a process in which a single string is divided into parts. But as I point out, it may be that the process of splitting is really, in fact, the annihilation of one string followed by the creation of two new strings that bear no mereological connection to the original string. So string theory doesn't exactly settle the matter. It's not enough to look at the physics here. We need to complement the physics with some extra theoretical assumptions. All right, so let's move on now to loop quantum gravity. Here, there is perhaps the most promising, there is a seed for a promising argument for extended simples that, in my mind, that's the most promising avenue in the direction. And the idea is that since the spin network structure is discrete, this suggests that the space-time structure it represents is discrete as well. But first, does the spin network represent a discrete T? So namely, the first notion of discreteness I introduced, topological discreteness. Does it represent a discrete T space-time or a discrete R space-time? Right, so something here must be settled. Because if it represents a discrete T space-time, then again, the case for extended simples is dead. Right, because the structure may correspond to a network of isolated space-time points. And second, the spin form approach, it seems, includes operations for splitting and joining nodes and edges. So again, all the issues with the splitting of strings in string series apply here too, or may apply here too. Well, there is some debate to be settled by the physicists before. So it's unclear whether nodes and edges actually represent extended simples there, even if we accept that LQG is a theory about spacetime. And finally, let me just mention also that apparently not everyone agrees that the LQG spacetime, if the structure is really a spacetime, will be discrete. Some people have claimed that it can be conceived of as being continuous. Right. So what I'm going to do now is to move to another view on the possible emergence of spacetime. I won't talk anymore about string theory because everything I'm going to say will have no bearing on the consequences I just drew about string theory. So we are just going to focus on loop quantum gravity from now on, and discuss whether other ways to look at the possible emergence of spacetime might have consequences for the existence of extended simples according to loop quantum gravity. So there are two different approaches that I want to talk about now that are also realist about spacetime. The first is mereological spacetime realism, and it states that spacetime is composed of non-spatial temporal entities. It's a member of a broader class of views according to which spacetime exists despite not being a basic posit of a theory of quantum gravity. And derivative realism that I'm going to talk about just after is another member of this class of views. So in this particular approach, the nodes and edges of spin networks do not represent a spatial temporal structure. Instead, what they represent is a non-spatial temporal collection of building blocks of space-time. Right. So the idea we see there's a link between the network or the spin network or the spin form structure and space-time. We say that it has some organization, some structure, but it's not space-time. It's other stuff, other sorts of entities that happen to compose space-time. Because on this interpretation, the spin network's structure is taken to describe the parts of space-time, a realist commitment to LQG will be taken to imply realism about space-time as well via the neurological connection, right? So the idea is that you commit yourself to the existence of what's posited by the theory, but also to the existence of what's composed from the theory, right? I mean, take for instance the theory saying that you can accept, for instance, that galaxies exist according to particle physics, right? Even though they don't directly quantify over that. Now I want to show that the simple argument fails here, because the simple argument for regions can be applied in two places. It can either be applied to the spin network structure, or it can be applied to the spatial temporal holes, that the spin network structure composes. Let's look at the two options, right? So the trouble with the first option is that even if the parts of space-time are simple, they are not spatial temporally extended, right? Also, they may compose extended regions, but it's not the same. So they are not extended simple regions. The trouble with the second option is that, according to the Mereological space-time realism, again, all spatial temporal regions have parts. They are composed of non-spatial temporal building blocks. So there is no direct road from LQG combined to a form of Mereological space-time realism. So not only it's already a cost or a commitment, right, to go in that direction, to accept Mereological space-time realism. But even if you do that, you are not done yet. You don't have extended simples yet, because the simple argument fails. But we think we can make something else work. And to get that, I need to introduce a distinction between spatial temporal Mergy and neutral Meteorology, right? I mean, some of you know a bit my work, and that I've been advocating this distinction in the past. The idea is that part of the Meteorology involve relationships between spatial temporally located natural objects, but not all of Meteorology. The thought then is that it's only spatial temporal meteorological relations to which harmony principles apply. So in other words, what we are suggesting here is that there is room for a form of non-standard meteorology, which denies many of the usual principles associated with meteorology, right? So actually we discussed this in another paper with Sam, where we try to argue that there is room for this non-standard form of non-spatial temporal meteorology. I was thinking about presenting this today, but I thought, many of you already know quite a bit about that, so I didn't want to annoy you again with that, and I thought it would be better to just present you this work, this other work on extended simples. But anyway, so we have those two sorts of meteorology, the spatial temporal one and the more neutral one. And the idea is that harmony principles, right? So remind that harmony principles, it's like it's principles ensuring the harmony between objects and space-time via location. So the idea that harmony principles are not constraints on Mergy more generally, so they don't need to apply to neutral Mereology. So the idea here is that harmony principle will only apply to spatial-temporally located objects, but they can break down for other sorts of cases, non-spatial temporal cases, right? So the idea is that space-time itself can be viewed as being composed of more fundamental non-spatial temporal entities specified by a theory of quantum gravity. But these mereological relations are neutral mereological relations and don't obey the harmony principle. So the consequence of this is that the distinction between neutral and spatial temporal Mergy presents an opportunity to differentiate between two ways for a region of space-time to be simple. It can be either neutrally simple, right? What it means is it has no proper neutral parts. I realize that maybe if you're not familiar with that, maybe you could be a bit lost. So let me just try to trigger your intuition pump about what it could mean for something to have neutral parts. Think for instance, about a dispositional property, right? That something located somewhere has the disposition to trigger an effect. You could think of this property as being point-like and still as having neutral parts, like it could have its categorical part and its target manifestation. So that would be one way to think in very abstract ways about what it could mean for something to have non-spatial temporal parts. Then there is a classical sense, right? Something could be spatial temporally simple because it has no standard spatial temporal parts. And something could be both simple, right? In both senses, having neither neutral nor spatial temporal parts. If you acknowledge this distinction, I mean, I perfectly get it if you don't want to. I mean, it's a bit unorthodox, but if you do, then you have room for a new sort of extended simples that we call complex simples. So what's a complex simples? It's an entity which is spatial temporally simple, right? It has no spatial temporal parts, but it's not neutrally simple. It has some non-spatial temporal parts, right? So if you think of loop quantum gravity, the idea would be like you could have your relation of distance or your point, which let's take a point, a space-time point. It will have no spatial temporal proper parts, but it would have neutral parts that would be the ingredients of the graph posited by loop quantum gravity, right? So complex simples are then neutrally complex but spatial temporally simple. If that's okay, what are we going to do with those guys? Are complex simples extended simples? What are we to do with them? Here, I think it's basically just a matter of linguistic. It's up to us to decide how where we want to draw the lines between different concepts. We could assume that complex simples are extended simples about emphasizing the spatial temporal simplicity. Or we could decide that complex simples differ too greatly from the standard notion of extended simples to categorize them as extended simples, thereby underlying their neutral complexity. For the sake of argument, let's suppose that complex simples are extended simples, right? Then is it the case that we have an argument from the physics alone that the world is made of extended simples? I think you can see that many different assumptions are starting to piling up, right? So we are very far away from the physics itself. So I think it should be clear again that you don't get a straightforward road from loop quantum gravity to extended simples here again, even if you think that a form of mereological space-time realism will turn out to be the right interpretation of LQG, that's already a big if, in my mind, it's already a metaphysical assumption. But even if this were to be granted, there would be even more background assumptions you would require in order to make the argument work. Right, so I'm almost done. I know it's a bit, my talk is a bit dense today, I apologize for that. I will not consider a final ontological model for space-time emergence, to say a few things about what is the fate of extended simples in this approach. So it's the position we call derivative realism. It's another member of the class of broad views that takes space-time to exist, but not all the way down, right? Contrary to full-blown realism. So let me contrast it to mereological space-time realism. Here's the idea that with mereological space-time realism, the connecting device between the non-spatial temporal ontology and the spatial temporal ontology, the connecting device, the relation, was a relation of composition. And here, what we have instead is a primitive grounding relation. So space-time on this view is grounded in a range of non-spatial temporal entities described by a theory of quantum gravity. So here it's important to say that it's primitive, right? So in the paper, we consider that primitive grounding is different from composition, right? We know that some people want to put the two notions closer, but yeah, I mean, here I'm assuming that they are different, and I at least offer two different ways to think about the situation. At the very least, if you want to start thinking about extended simples, I think composition is more handy because, I mean, I'm anticipating a bit what I'm going to say, sorry. Derivative space-time realism actually doesn't bring with it specific commitments concerning what space-time is like, only that there is some, namely some space-time, and that it's grounded in the fundamental structure described by LQG. So in a way, if space-time is grounded in the LQG structure, it doesn't seem inconsistent for me to think that this space-time could be continuous, right? Because if you have this kind of powerful primitive notion, it seems that it introduces a kind of gap between the two structures. So it becomes hard to infer from the discreteness of the LQG structure. I mean, let's assume the LQG structure is discrete. It seems difficult to move on from this discrete LQG structure to a discrete space-time if the connecting device between the two structures is a primitive relation of grounding. So at the very least, the mereological nature of space-time, namely whether it bottoms out in extended simple regions or anything else, is not obviously settled by the nature of the ontology of the more fundamental level of description, again. So perhaps if we assume derivative space-time realism, and we further assume that space-time is discrete or, right, the region-based notion of discreteness, then the harmony argument seems to go through. But again, that's because we are assuming a lot here to make the argument works. Because we are assuming that there will be some kind of discrete space-time at the derivative level. But why exactly should we think that space-time is discrete if it's actually grounded in something else, which is not spatial-temporal and which is discrete? At the very least, it's not obvious, I think. So a case for extended simples region based on a derivative realist approach to LQG can thus be made, but one must accept both the existence of a primitive grounding relation and the discreteness or of space-time. And while the second assumption might perhaps be borne out by further development in physics, who knows, at the very least, the first assumption appears to be a substantive metaphysical thesis. So let me conclude globally. So I hope it's at least clear for you now that the situation is not clear, because it's unclear whether theories like LQG and string theory posit spacetime enough for simples to exist in the first place. And it's only when we couple the theories to a view on the existence of spacetime that the case for extended simples can be made. So at best, one can mount a conditional argument. If the metaphysics of the physics is in a certain way, then the physics implies the existence of extended simples. But then it's not the physics alone that implies the existence of extended simples. It's really the physics plus a lot of metaphysical add-on. And on this, I will stop. Thank you.
Thank you very much. Great. Okay. As always, if you have a question or a comment, please write Q in the chat. If you have a finger or follow-up, write an F, please. Okay, let's get started. Claudio, please.
Thank you so much, Baptiste. I really liked it. So let me ask you. So one thing goes in your favor. One thing I want to push you a little bit. I mean, ask you your opinion. It's not an objection here. So the first one is that I think you're completely right about harmony principles, and I don't see actually any reason to buy them just in the spatial temporal. In the spatial temporal.
Sorry,
the harmony. Yeah, I'm sorry. Mm-hmm. So I don't see. I don't see any reason to buy harmony principles in the first place. Clearly, not just from the Mereology alone. If you don't actually put forward H as a reductive definition of partude, these are just monotonicity principles that relate partude and location, and therefore they're not about Mereology per se. They're about the interaction between Mereology and location, and your Mereology alone doesn't force you to have H. So I think that this will go actually in your direction. There is no the reason, and now we have a bunch of violations of Mereological harmony. Here's a stupid topological one. Suppose a lot of people think that don't ask me why, but material objects are topologically closed. Now take a region, take a location of a region. Now it will have open subregions. Therefore, there will be a violation between at least topological structures. So that will go in your direction. Now, the one to push you a little bit more is people keep rejecting my papers on the metaphysics of extension. So what the notion of extension that it's at play here? Meaning, like, it seems to me that there are several ones, and for example, at a certain point, you guys in the paper say spatial temporal region is extended when the metric distance between any 2 points in the manifold representation is non-zero, which seems actually to push in the following direction. First of all, it's a metrical definition of extension, right? Mm-hmm. Which, for example, will tell you that 2 points might be, so if you take the sum of 2 points, it might be an extended region, but of course its measure is going to be 0, which is another intuition in which the region would be an extended. There's another point in which, another worry here. Suppose, so are you...
Sorry, can you say it again? What was the first worry?
So the first worry is that there are different notions of extension, right? And they don't match up. Like I can use, here's a notion, here's the one taken from your paper, page 7. Spatial temporal region is extended when the metrical distance between any 2 points in the manifold representation there. Mm-hmm. So now take 2 points. Take a region made by 2 points. This will be an extended region given your definition, but the measure of that region is going to be 0, right? Mm-hmm. And there's an intuition that says, well, if the measure is 0, it's going to count as an extended, right? I mean, mm-hmm. that surely it's going to be an extended region.
But is it a worry for us or a worry for the consistency of the very notion of extended simple?
So the thing is, so if you have that notion, right? If you have that notion, first of all, if you think that the 2 points are parts of the region, it seems that extended simple regions are just impossible. because they're going to be 2 points such that the distance is going to be greater than 0.
Right, but isn't it what we say that the case for extended simples was dead on arrival if we accept the notion of topological discreteness, which is the notion you're using right now? No,
it works on just any metrical notion, given that the metric notion of extension that you use just says that if 2 points, for any 2 points, have a distance greater than 0, it's going to be that it's a necessary condition for a region to be extended to be.
But you don't have points in the other notion of discreteness we considered, right?
No, that's fine. That's why. So the point is just that there are many notions of extension, right? So the one that you gave, there's another one which is cashed out in purely, again, metrical terms, just metric spaces, not measurable spaces, metric spaces that say something like, for example, wait, I had so a region. A region is extended if it contains an open ball as a part. Now, all these things, they don't match up. That's the
yeah, but here's my worry to your worry. If you consider the a more measure type sort of notion of extension, then it's just inconsistent with notion of extended simple, no?
No, that, I mean, if you have points, then they have Lebesgue measure 0. I mean, they have measure 0. But if you have non-atomic measures, then you have then it's going to be fine. Then you can have something which is extended and atomic. So the Lebesgue measure, you're right. The Lebesgue measure will say that if it's extended, it actually has uncountably many parts, as a matter of fact. But there are other measures that are not like this. So the measure theoretic notion of extension, I think, will give you extended regions, simple extended regions. Of course, you cannot go to, you have to go to fancy metrics, like, non-atomic metrics, but non-atomic measures, sorry. But for example, some metrical definitions, unless you go for a fancy one, which is due by Christy Miller, which is an extrinsic definition, in and on itself, it seems that it will make extended regions impossible, and therefore extended simples impossible because they're defined in terms of extended regions.
Right, yeah.
So the thing is that there are different notions of extension, and it would be cool, actually, I shouldn't use the word cool, but Kevin is not here, so it's fine. It would be nice to actually play with these different notions of extension because they don't match up.
But here, but is it necessary for a project? I mean, because from my perspective, what you are saying is that we could have introduced more notion and play with more notions, right? And so that's fair enough, and that would be cool, as you said, to do it. But is that really necessary for establishing what we try to establish? I'm not sure. I think it was enough to have stay at a more fuzzy level, let's say.
No, sure.
But I agree with you.
I just mentioned that it would be an interesting project to see, different notions of extension, how they play.
Yeah, I mean, then I completely agree with you for another project, which is to analyze the emergence of space-time, right? But yeah, but I mean, two things. Then I want to hear your second worry, right? But also about this idea of mathematical objects needing to be closed, topologically closed. I mean, I'm not sure about that. I mean, it's kind of convention, but you can use some non-closed topological objects, I think. But...
No, sure. I just mentioned that there are views out there that actually immediately entails that mereological harmony principles are simply false.
Right.
So there's, I mean, assuming them is not as uncontroversial as it might seem at first sight. As a matter of fact.
Right. But I mean, in fact,
they will go in your direction, actually.
Yeah, but I mean, I think non-spatial temporal Mergy, as we discussed in the paper, is even more controversial because we have to also reject the downward inheritance principle and many other classical principles associated with Mergy. But I mean, already that's good if harmony is not, if letting go harmony is not too much of a big deal. Thanks.
All right, great. Thank you very much. David, please go ahead.
Thank you for the presentation, Baptiste. I was wondering also from the paper itself and from the presentation whether this is, I imagine this is perfectly obvious to you, so just hoping for clarification here for my sake. What hinges on the question of whether there are simples, extended simples, whether there is another kind of interesting connection to, I don't know, broader metaphysical issues that like commitments that we need to adopt if we go in for this, for one response to this view. And I think that's also connected to, so you discuss some people who just straightforwardly say there are these, obviously physics entails that there are extended simples, Rattling, I think, and Green and Calendar. And I was just also wondering, I guess, relatedly, why they think it's important that there are simples. Maybe it plays some role for them, or is it just a kind of en passant, observation that they make? And having an answer to that question might make it, might be relevant for checking whether a kind of a notion or different notion of the kind perhaps that you introduce these distinctions later, whether something like this would satisfy what they're looking for, or whether that would saving their what they're looking for only in letter, in name only rather than in substance. Anyway, just a couple of thoughts.
Right, yes, thanks. I mean, actually, when I started preparing the talk, I thought about, addressing a bit that in the introduction. And I realized, well, why am I excited by this question, right? Because maybe not everyone will be excited about the question, right? And I mean, fair enough, it's a bit a niche question, right? I mean, in my case, I guess it's my own motivation is that I want to understand the nature of space and time. And it's part of material objects and the relation between space, time, and material objects. So the way different ontological categories are articulated. So I want to understand what's going on at the deep level of space and time. I think that extended simples are a bit challenging conceptually, but in a way, an infinity of points is also challenging. I mean, so I think all the situation, all the particular ontological models you will start looking, they will all have some kind of funny business going on. And so for me, my interest is, I have some very, I don't know, primitive physical interest and metaphysics interest about how this works. So I don't really have a particular other motivations. Although, I mean, at the end of the day, I think it might perhaps help understanding part of the physics, like stuff like the thermal profile of Hawking radiation, this kind of stuff, right? Can you think of a black hole as a collection of discrete entities, this kind of stuff? So yeah, I would like to understand let's say the topological profile of space-time to have a better understanding of the view of the world. Sorry. So I don't really have a better thing to say. I mean, my case, in this case, it's an interesting interest. It's not really to solve a deep philosophical problem I have otherwise. And for the motivations of Rattler, a calendar, I mean, I think it's similar motivations. I cannot tell immediately. For Rattler, I'm pretty sure it's an interest for the metaphysical question.
Okay, my guess is the calendar just expresses what it takes to be an evident truth about, the standard interpretation of string theory, but that's just a guess. Anyway, so Claudio has noted in the chat that there is a literature on unextended complexes, in case you're extended simples are too common, I guess, or sort of too ordinary. You can think about unextended complexes. Anyway, Lorenzo Cocco has a question. Please, Lorenzo.
Thanks. I had a question on your popularization of string theory at the beginning. Of course, I don't need to say that I don't know anything about string theory, but I think I followed the outline of your argument about why when we are supposed to move, or the physicists are supposed to move to M theory, an interpretation in terms of unextended strings might not apply. But I wanted to ask you, do you think that the issue is that clear also for like the perturbative theories? Especially my question was, do you think that this interpretation remains also when we take into account the measurement problem, or when we look at that really closely? Do you really have an ontology of unextended strings, or do you think it is also could be more subtle there?
I don't know how to answer that. The situation is a big question mark, right? So it's more like we have a collection of hints about what's going on. I don't see why. Tell me if I'm wrong, but I think you were suggesting that solving the measurement problem in quantum mechanics could dissolve part of the motivations to move from string theory to the non-reality of space-time.
Well, maybe let me clarify a little bit, because it was really large, maybe what I had in mind. So I was thinking rather about this. So not exactly that, but more the following. When, I don't know, during these last 5 years, I had enough of my shares of talks on string theory, which I cannot understand, but they all begin by assuming as obvious that, say, QFT is a theory of point particles, right? Or something like that. Okay, QFT is a theory of point particles, and then they say, well, string theory is a theory of strings, and the difference is that now we can account for certain type of scatterings better, something like that. But of course, doesn't seem to be clear when you look at it really closely that QFT is a theory of particles. So you had these theorems by no less than David Malamud himself, right, that says that you cannot have a particle interpretation of QFT, and then there are, it doesn't work on curved spacetimes, things like that. So theorems that supposedly rule out a particle interpretations, but not that I follow the theorems, but you have this disagreement with Bohmians and say, no, this is not true. Actually, the theorems do not apply when you take into account the measurement problem. So it doesn't seem that already, it's complex to discuss whether QFT is a theory of point particle, which is assumed as evident. So my question is, well, then is it so obvious then, if we look at the theory with the same degree of closeness, that, I don't know, some perturbative string theory in 10 dimension really posits strings in the same sense? That's what I was thinking. I don't know if you have an opinion of that. Maybe you have no opinion of that.
I don't know. I can just say a few things I know that may be tangential on what you say. Right. In a way, I think I would see more continuity than what your description suggested between quantum field theories and string theory. I would say that string theories are quantum field theories, but with different of a different sort. I agree. I don't like particles myself, so I'm happy having kind of eliminativist take on the existence of particles in the quantum field theory, in the standard model, saying that they are just fluctuations or quanta fields, right? Like that. For string theory, I would say the same, right? You could say that strings are quanta of those stringy quantum fields, right? But then I still think there is a question about whether you have some kind of extended simples corresponding to the fluctuations. But what I'm trying to say is that I don't think that the extended simple debate relies necessarily on a commitment to the ontological category of the object, either as a point-like object in the standard model, or as a one-dimensional object, or with strings, or higher dimensional objects like brains. So I think that the same philosophical move, saying that the fields are more fundamental than the particles, or the strings, or the brains, you can have the same move here and there. So, I mean, I agree there is a level of popularization talking about particles. I mean, some people think that particles are real. I don't, but some people do. And I guess I would say the same thing for strings in a way.
So, okay, thank you. I have a question. I would like to, so one thing, that the thesis about extended simples seems to consist of two parts, right? The simplicity and the extendedness, or something like this. Now, I certainly agree that the extendedness is deeply problematic in a theory that is likely has to be interpreted in something like a non-spatial temporal way at the fundamental level. It's not so clear what that would even mean, and you know how we can make sense of that. And unless we make very specific substantive assumptions about the metaphysics of extendedness or something like that, we're not going to get to the conclusion. That seems very plausible to me. But about the simplicity, I think you're a little bit quick in some places. For instance, when you talk about, you make an inference from strings being able to split and join, and nodes in loop quantum gravity of spin networks being able to split and join. And you say that, well, you know, splitting and joining are things we typically from macroscopic experience know is only possible of things which are complex. So therefore, these are not simple. I mean, that's not quite the way you put it, but it's brushed away to the side very, very quickly. And I think just from I mean, without going to the Huggett-Norton kind of response where you have something that may be a simple that's being replaced by two other things or something like that. No, when you really have a splitting, you know, why think really at the fundamental level that splitting and joining are things which only complex objects can do? I mean, what would it mean to be simple for the thing before it's split? It means something like having no internal structure, right? And it could be that this thing does not have any internal structure. And nevertheless, there's a sense in which it splits. And that means, of course, there's no way of saying that it's split into the right part and the left part or something like that. I mean, that kind of interpretation of splitting would not make sense. But is it a priori so clear that a simple thing cannot split and join that we necessarily have to go something like a Huggett-Norton interpretation where we have a replacement of one thing by two things or both two things by one thing? So, I mean, it's, to be honest, it's just not obvious to me at all.
No, I mean,
case.
I mean, I guess I agree that there are two notions in the neighborhood. I mean, I mean, point taken may have been too quick, not considering the notion of splitting. I mean, let's call it exotic splitting, right? Because it would not be exactly as the standard macroscopic way we think about splitting, right?
Sure, it's not splitting into a right and the left half or part, which it had before or something like that. That's clearly not the way we should think about it. But maybe that's not necessarily.
I mean, the ordinary notion of split, I think it's conceptually related to Mereology. I mean, because what you describe, is it really a split is it really a fission, or is it more like a duplication? I mean, it seems perhaps closer to the concept of duplication, something like that.
Maybe. I mean,
but it's tricky territory. I mean, I agree. There's probably more to say.
Maybe splitting is the wrong word, which we use. Then we could say, yes, splitting is, is really connected, conceptually to this idea of having parts into which it splits, and it had to have these parts prior to the split. And if that's the way that English word functions, then maybe splitting is the wrong word for what's going on.
Because I wonder what would be the difference between the scenario you just described and Nick and Josh scenario, where basically, I mean, you can talk about individuals or temporal parts, right? But what you really have is this entity is here, then it's not here anymore. You have two other entities that are related, right? You can have different pictures, but would it be really a split? Or, I mean, my intuition, my conceptual intuition would be that I would not apply the concept the ordinary, the way I use it usually. But I think there are a few fingers.
At the end of the day, it's. I think at the end of the day, it may be just what Nick and Josh had in mind. But let me start with the follow-ups on this. Claudio has one. Please go ahead.
And there's just an entire chapter on Casati and Varzi on this. So without Mereology, just doing by topology. They call it topological catastrophe. It's just the cutting and fissing. So it's chapter 5. Okay. So I mean, meaning that there's an alternative way who just does it with topology, which will be interesting for you to see. I think it's chapter 5. I can't remember, but it's clearly in the book. I don't remember when, but it's
Casati and Varzi, you say?
Parts and places, the structure of spatial representation. It's the first book on theories of location. So when they do topology, I think they have like a drop of oil that actually splits, and some other they have two drops of oil that combine, and then they just do it with topology, and they say that you don't need to actually have either at the result or at the end to monological structure. So there might be some ways. I can't remember how it goes, but I remember that it's there.
Okay.
Thanks. We'll check it out.
Thank you. Ryan has a follow.
Similar vein, which is to say, I mean, Aristotle in On Generation and Corruption, right? He says that the elements that make up a mixture don't have like places within the mixture. The mixture doesn't have any kind of like structural parts, but nonetheless, it's not just corrupt. It's not just corrupting when the mixture changes into the parts, because the parts had a kind of potential presence there. So he distinguishes between potential and actual parthood. And he says that it's simple with respect to actual parthood, but it still counts as being able to, separate and join because of the potential parthood. So, I mean, there's a whole road there to go with, but just to say that again, there's a literature on approaches to that kind of thing.
Good, thanks.
Well, I'm glad to hear that. I didn't know all of this, but it seems like there's other people with authority who agree with me that this is not a question to be dealt with quickly and easily. At least there seem to be options. Okay, but if there's okay, yeah, everybody's like, well, their favorite book, which contains some relevant material. I think there's some restrictions there.
I even uploaded one, so.
Okay, great. Thank you very much. Everybody can upload their favorite books. There was a question by Alberto. Please, Alberto, go ahead.
So, hi, thank you a lot for the talk. I enjoyed it a lot. I wanted to ask something similar to what Chris asked, but you already replied, so just let me make a question out of curiosity. You said you're more and more into the space-time eliminativist picture. So I was wondering why you're liking that picture more, and if you have any thought on the threat on empirical incoherence.
Well, I mean, So we have been collaborating with Sam for a while. So I think the funny thing happened. So Sam basically was advocating eliminativism. I was advocating merological space-time realism. So he wrote a paper against space-time, merological space-time realism, basically. And then we started working together. I think I convinced him that he was wrong. So now he takes the view as being promising. But the bad thing that happened during the process is that Sam also convinced me that eliminativism was looking far better than what I used to think. So he just got a paper accepted in Erkenlis, Sam, I mean, about that space-time eliminativism, and I think he's talking about the problem of empirical incoherence there. But very roughly, the idea is that to solve the problem of empirical coherence, you don't need to recover space-time. What you need to recover are the relevant causal interactions, right? To set up the measurement device, etc., etc. So what it means is that causation should play a role in this story, perhaps rather than that space-time. And so something we're working on at the moment is that you could go fully eliminativist about space-time if you help yourself with other notions like strong relations of causation, something like that. So that's the plan. So Sam already has a couple of papers like that. So you want to check it out. I think you'll find that interesting. And we also plan to continue the work in that direction. But I mean, for me, I remain a skeptic philosopher, right? So I was suggesting we can build up some metaphysical models. Space-time eliminativism is quite interesting. I think it's a good option. Merological space-time realism is good too, I think. I guess probably the only model I don't like that much is a grounding model, the primitive grounding model. Yes, thanks, Claudio. Actually, is it this paper? The one in Arkansas?
I think he has another one, but I couldn't find that one.
Yes, no, the other one maybe it's not out yet. That's a good start. But I think in this paper it's more about space-time functionalism. So yeah, another paper that will be out soon, I think.
Nice, thank you a lot.
Thank you.
Yeah, I can tell when I read your paper that you're very lukewarm about the derivative space-time realism. And I think that's the position that should be given, more credit. But yeah, there we go.
Yeah, I mean, then you have to write something about that. Because
yeah, I guess so.
I disagree a bit.
Yes, I know. Okay, does anybody else have a question or comment or objection or complaint or suggestion?
Maybe no complaint.
Okay, sorry, no complaints. Any suggestions or? Yes, Rasmus, please go ahead.
So this is a question of clarification for the when you talked about the neutral Mereology and you talked about these extended symbols being composed of non-spatial properties, non-spatial temporal parts, right? Should we understand these extended symbols then as some kind of emergent properties in a way that we can so we could actually tell some kind of meteorological story about what kinds of non-spatial temporal parts would have to be in place in order to capture a extended symbol? So when do we have an extended symbol? Could we tell any good story about that?
Sorry, what's the question? Can you repeat the question?
Yeah, so the question is I'm just very curious about how we are supposed to understand the mereological picture or the compositional structure of what an extended symbol would be when we're talking of it as in terms of being composed of non-spatial temporal parts. So is it the idea that there is some kind of approximation or limit to where we have when we would have an extended symbol composed out of these non-spatial temporal parts? Like, is there any genuine story we could tell there?
Right. I mean, here the thing is that there are many different things we could be asking for here, right? It could be either you want an intuitive story, right? How do you account for the shift from the non-spatial temporal to the spatial temporal, right? But you could also be asking for a mathematical derivation or formal principles. I mean, it's not clear what we are asking for, right? But what's clear is that it's puzzling to consider the relation between that. I mean, I think in loop quantum gravity or in causal set theory, it's perhaps the easiest way to make sense of intuitively of what it could mean, that of what the story could be. So I mean, I guess there are two paths, right? The first part should be given by the physics and the mathematicians, right? Having a clean theory with clean ontological commitments. And we should have that for both theories, right? And then if we have bridge principles, then we have part of the story, right? And people with an anti-realist inclination will say that it's all we need. We don't really need to add a metaphysical story on top of that, right? But then if you want a metaphysical story on top of that, you will have to complement your story with more philosophical bridge principle, like perhaps explaining how something that is extended in this theory correspond to stuff that are not extended. I mean, I don't really know how to say more. I mean, my first the first time I discovered this idea of non-spatial temporal Mergy was with Laurie Paul's paper, and she's talking about objects, how objects can be composed of their properties. As I discussed in the paper, right, you can think that the location, the shape, the color, all those three properties could be parts of the object that will be bundling together to compose an object. Also a way to get some kind of idea. But that's also interesting for Claudio, right? When you say that we could have this idea of location being more fundamental than space. In a way, Laurie Paul's view belongs to this family of views, right? Because you build up space as a derivative structure from primitive location properties that bundle to different properties to create regions and spaces. So that would be one way also to think quite intuitively, perhaps, of non-spatial temporal Mereology. I don't know. Am I answering to your question at this?
Yeah, sort of. It's just maybe because like I have very strong functionalist inclinations. So I especially in the case of quantum gravity, because I find it really hard to actually understand the mereological story without understanding it in spatial temporal terms. So maybe I need to read up on what you mean by this neutral Mereology and like how it but you know.
I mean, you have in mind what's quite. Mereology is very often introduced in conjunction of many intuitions based on concrete cases, right? Mereology is the tool used to make sense of the structure of concrete objects. So a lot of our intuitions and understanding of Mereology are associated to the way concrete objects make up other objects. And the kind of Mereology I try to put forward is definitely a departure from this standard sort of Mereology, right? It's a kind of messy, unsatisfying Mereology for the purist of Mereology, because it's something else in a way, but it's something else that should give rise to the standard Mereology under the right restrictions, right? So the idea that all our intuitions that Mereology is spatial temporal are justified because Mereology most of the time behave as spatial temporal Mereology. So that also explain why we tend to restrict Mereology this way. I mean, that one way to explain the kind of answer I can give to people coming at me and say, well, look, Mergy is essentially spatial temporal. As an answer, yes, in most cases that's true. But theoretical physics might tell us that it would be good to extend a bit Mergy and think of standard Mergy as being a restriction on a more general sort of Neurology. But and functionalism has also its issues, I think. I mean, functionalism is good for many purposes. It's more minimal. It's less metaphysically loaded, or at least you can keep it less metaphysically loaded. So that can be the right tool if you want to avoid the deep waters of metaphysics. But I think if you want to adventure yourself a bit in the metaphysics territory, then I don't think functionalism will clarify everything you want to clarify. That's my personal opinion, and why I think that functionalism cannot do the job of explaining everything there is to explain about space-time emergence.
Enrico, can you make it really brief and snappy?
I'll try to do my best. So it was just really to reiterate the point that you made, that the argument on simplicity is maybe a bit too quick. It was just to say that the diagrams, both in strings and I think also the spin forms that you correctly drawn, those are typically regarded as the quantum gravitational analog, as far as I understand, of Feynman diagrams, which are usually not taken to be literally being there, representing a physical process happening in space-time. So especially in strings, I would be very, very careful saying that, oh, you see the diagram splits and joins as an argument in favor of the fact that there is actually something splitting and joining, because if you do the same in quantum field theory, where those would be a Feynman diagram, it would be very, very bizarre, I guess. And the same should apply also to spin forms, if I'm not mistaken.
Yes. Right. I mean, point taken. Probably I was too quick. I mean, the only thing I can say is that I also relate to Alberto's comment about the notion of object. Right. I mean, I think there are two ways to look at this. Right. If you can show that what seemed to be simple is in fact complex, then of course the case for extended simples is also dead, right? So maybe there is another road we should have explored to block this idea of extended simples, based on the fact that the real notion of strings and branes are already kind of idealized approximate notions, and that we should not draw ontological commitment from those notions, right? Yeah, I mean, thank you all. I mean, it's very helpful. I think you're right, of course.
All right, I think we're actually more than out of time, so please join me in thanking Baptiste again.
Thank you all for the questions. Very helpful.